Question 9. So we are given a function f, and in A we need to find the derivative of f. So if f is 12x over x squared plus 2 to the power of 3, and I want to differentiate f, I will use the quotient rule. Accordingly, I have to differentiate the nominator, that is 12, times the denominator untouched, then I put a minus, I copy the numerator and I multiplied it by the derivative of the denominator, and this will be 3 times x squared plus 2 to the power of 2, and times the derivative only of the terms inside the parentheses, which is 2x, and I divide this by the denominator squared. So now I will simplify it. So I have 12 x squared plus 2 cubic minus 72x times x squared plus 2 squared, and the denominator stays the same. So now I continue to simplify. So here I will take out as a common factor x squared plus 2 to the power of 2. So from the first term I'm left with 12 x squared plus 2 and minus 72x. From the second term, and again the denominator. So here I get that I can strike down this, and here I left with 4. So now the denominator is 12x squared plus 24 minus 72 x. Sorry, this should be 72x squared. Yeah, it goes back to here, where this is 72 squared, 72x squared. So I get here minus 60 x squared plus 24, and if I take 12 out, we have minus 5 x squared plus 2, and the denominator stays as it was. This is exactly what I needed to show. Now, moving on to B, we need to calculate the integral of fx dx. So, f of x was 12x over x squared plus 2 cubic dx. So in order to integrate this term, I use the substitution x squared plus 2 equals t, and then if I differentiate this equation in both sides, I will get 2x dx equals dt. So now I can substitute inside the integral. So I have 12x over t to the power of 3, and instead of dx I write dt over 2x. So now I can cancel out 2x and this, and it will be 6. So I need to calculate the integral of 6t to the power of minus 3 dt, which is 6t to the power of minus 2 over minus 2 plus c, and if I simplify further, I will get minus 3 over t squared plus c. So this is the integral of fx, and of course I want to return to x, so instead of t I put x squared plus 2 and this is my final answer. Now moving on to part C. In part C, we are given that g prime of x equals f prime of x. So if I integrate here, I will get that g of x equals f of x plus a constant c. Now, if c is positive, then I know that the function g is above the function f, because here the value of c, when it is positive, I need to take the function f and to move it in the y direction c steps up. So it will be above g in c steps. So the integral, in order to get the area, I will have to do g minus f dx, again because g is above f, and this between 0 and 3 will be 21 over 2. So g minus f, I can see it here, g minus f is simply c. And the integral of c is cx between 0 and 3. It will be 3c, and it equals 21 over 2. So c is 21 over 6, or if I divide by 3 the numerator and denominator, I will get 7 over 2. This is the first value of c. Now if c is less than 0, so then again I look here and I can understand that g is now under the function f, because the function f was moved with c steps forward the negative y-axis, because c is negative. And now when I write down the integral, I need to do f minus g dx, because f is now above g, or g is under f. In this case, everything else stays the same. But in this case, if I will do f minus g, I will get minus c. And if I solve the same way as I solve here, I will get that c is negative 7 over 2. So those are the two options for the values of c. And therefore we have two possibilities for g. So g was f plus c, and f was 12x over x squared plus 2 to the power of 3. And for c we had two values, plus or minus 7 over 2. So those are the two possibilities for the function g.